Okay, now let's finally talk about deleting documents from MongoDB in the Node.js driver. As an example, I'd like to take a look at cleaning up our company's collection a little bit. As we encountered previously, there are some duplicate records in this collection, and we can see one example if we do a search for the permalink Thomson Reuters. Now, permalinks should be unique within our collection. However, if we do this query and then project out the name and the updated at fields, we'll see that there are in fact two records, both for companies named Thomson Reuters, same company, both of which were updated at exactly the same timestamp, but with different object IDs. Now, for a real data cleaning operation, we'd probably want to do a fairly rigorous assessment to see whether there were some subtle or significant differences between these two records and other records that appear to be duplicates. But for purposes of learning a little bit about the delete operations in MongoDB, we'll just assume that any records that have identical permalinks and updated at values are duplicates. And we'll build a little application to eliminate those duplicates. Now, before we get into actually deleting any records, let's get a sense for the size of the problem in this data set. Now, one way in which we can approach this is to do a query for all permalinks. If we sort them, those that are identical should occur in sequence. And if we use our cursor for each method, we'll stream them in without using very much memory at all, really. And we can simply compare successive values for permalink to see whether or not we have duplicates. This is a pretty standard technique for identifying duplicates when you have a collection of items. Okay, so what I'm going to do here is create a query document. I'm going to specify that I want to see permalink values that exist and that are not equal to true, something we've seen several times now. And I'm going to project out the permalink and the updated at values. And because I'm not excluding it, the underscore ID value will also come through. Okay, so then we go into defining our query, passing in the query document, and then we're going to apply a projection, and finally a sorting. Here I'm sorting by permalink into ascending order. Now, I want to keep track of the number that need to be removed, so I'll do that with this variable here. And I'm also going to create a variable called previous, to which I can compare each document as I iterate through them in my callback function here. Again, remember, if I see the current document having the same permalink and updated at value as the previous document, then I'll know I've got a duplicate, and I will identify that second document as one to be removed. Okay, so looking at the iterator for each, I can see that I've got a permalink here. I can see that I'm comparing the permalinks for the current document and the previous one, and the updated at value for the current document and the previous one. Okay, if both of those are equal, then I'm going to go ahead and log that permalink, update my number to remove, and then I will call delete one here. Okay, but first what I'd like to do is just get a sense for how many documents we have that are duplicates. Okay, and then at the bottom of this iterator, of course, I'm going to update the previous document to the current one that I've just finished processing. So the next time through, previous will be that one that I've just concluded processing. Okay, so let's run this. And we've got a big error here. Let's see what's going on. We've got a big stack trace that just printed out. Let's see what the problem is. Okay, so this is interesting. Let's take a look at it. Executor error during find command. Operation failed. Sort operation used more than the maximum bytes permitted. Okay, so let's talk a little bit about what's happening here. Note that we're stipulating that we want to do a sort here. Okay? In a later section, when we talk about indexes, we will learn that we can actually do sorting on the database side, so within MongoDB itself, provided we have set up an index that MongoDB can use to do our sort. So for example, one index in this case would be an index on permalink. We don't have such an index set up. So what's going to happen is the system is going to try to do a sort in memory rather than in the database. So as a little bit of foreshadowing, what I'd like to do here is just go into the Mongo shell, and I'm going to create an index. Again, a little bit of foreshadowing. We're not quite ready to talk about indexes yet, but if I execute the create index command, then I will create an index on the permalink field on this collection, and this will enable MongoDB to be able to sort my query using this index merely by walking the keys in the index. And that's all I'm going to say about indexes for now, but this will solve the problem that we've just seen over here. So now, if I try to run this, okay, what I get out is a list of all of the permalinks that seem to be duplicates. Okay, so let's check a couple of these. How about this one, RSS Mixer? If I go into the Mongo shell and I search for that permalink, again, 2 documents, same updated at value. Going back here, let's check another one, swap logic. Okay, and again, duplicates. Okay, so now I think we're ready to actually go ahead and delete these documents. So let's talk about how delete one works. So again, remember that what I'm going to do here is loop through a sorted list of all of the permalinks. And when I find 2 successive documents that have the same permalink and updated at, I know I found a duplicate, and I'm going to call delete one. Now, delete one takes a filter, which is basically a query document, and it will delete the first document it finds that matches this query or filter. Okay? Now, remember that I am not getting rid of the underscore ID on my projection here as part of this query where I'm getting the sorted list of permalinks. So I have that underscore ID available to me, and the reason why I didn't get rid of it was because I want to specify the underscore ID as my filter to delete one. There will be only one value that matches that because underscore ID values, of course, have to be unique. So I will delete the second of the 2 documents I found that have the same permalink and updated at value each time I find myself in that situation in this iteration callback. Okay, and then in the callback for delete one, I'm just going to check for an error and print out the result that I got back. Okay, now let's run this. And this time when I run delete one, it's actually going to do the deletion. Okay, and we can see here that we got back same output, but we're also getting back what looks like responses from a call to MongoDB. And in fact, that is what we're seeing because we're printing out the result of having done our delete one. When we see an OK of 1, we know that it succeeded, and N of 1 indicates how many records were deleted. Because we're calling delete one, we expect to see just one document deleted each time. Now, if we try to run this again, what will happen basically is nothing. Because we've already deleted all of those duplicates, if we go back to our Mongo shell and check these values, now swap logic has just 1. Let's look at RSS Mixer. Again, just 1. How about Thomson Reuters? And just 1. Because we've deleted all of the duplicates. Okay, now you may have noticed that calling delete one every time through this iterator is a pretty inefficient means of performing this task. Okay, there are more than 900 duplicates here. So we're doing a round trip to the database more than 900 times. That's crazy. So delete one is perfectly fine for small one-off operations where you need to delete a document. But when you've got a larger task, like what we have here, what you really want to use is delete many. Okay, so here's an alternate version of that same application. The only real difference here is that rather than deleting documents each time through my iterator, instead what I'm doing is I am simply marking the documents for removal by the underscore ID field. So I'm keeping track of a marked for removal array. Every time I find one of those matches for permalink and updated at, I push the document ID onto my marked for removal array. So the callback that gets called as soon as I'm done iterating is the place where I really want to be doing my delete. And you can see here that I'm making a call to delete many. Now, delete many, like delete one, also takes a filter or query document as its first argument. What I'm doing here is I'm saying, as my filter, look at the underscore ID field, and for every underscore ID found in this array that I'm going to specify as the argument for $in, delete those documents. Now, delete many, in contrast to delete one, will delete all documents that match our filter. Okay? So I'm going to use the $in operator on the array that I've built up here, pushing an additional document ID on each time I find a match. And then I will call delete many, identifying every single one of those document IDs for the documents that need to be deleted. And in this callback then, I can report on the results of the delete many operation, report how many documents were removed, and finally close the database connection. All right, so now let's run this. However, if you'll remember, I've actually already deleted all of those documents using the earlier version of this application that we looked at. So what I'm going to do is basically just reset our database. We're using the Crunchbase database. So I'm going to simply drop the database, and then I'm going to Mongo import it once again. Again, remember, the way Mongo import works is I specify the database and the collection into which I would like to dump all of those JSON records held in whatever JSON file I'm passing to Mongo import. In this case, it's my companies.json file. Okay, so my collection is built again. If I go and look for Thomson Reuters, sure enough, I'm going to see 2 of them again. So now, let's call this delete many version of the application. And again, I'm getting that same sort operation issue. So I can take care of that by, once again, creating the index. When I drop the database, all the indexes disappear as well. So I need to recreate the index. And now I run my delete many operation. Note that the operation succeeded. There were 907 documents removed. And I'm actually reporting that as well based on the length of the mark for removal array. So what the database reports as the number of documents to be removed matches what I calculated inside my own application as the number of documents that needed to be removed. Okay, and now if we go back to the Mongo shell, we look for Thomson Reuters, just 1, RS Mixer, just 1 of those, and Swap Logic, just 1 of those. Okay, so that is a good overview of using delete one and delete many, what they need to be passed as parameters, and what they return to the callback that we provide.